Hello, today we will be looking at homework 5, question 8. So two blocks with masses MA and MB are connected to each other and to a central post by cords, as shown in figure 1. They rotate about the post at frequency f revolutions per second on a frictionless horizontal surface at distances RA and RB from the post. First step to solving this equation or this problem would be to draw your free body diagrams. So, drawing the free body diagram for block A. Mark that block A. It has we're gonna assume that the left is where the post is. So if we were to mark and zoom in on here, this would be tension 1. This would be tension 2. Tension 1 being the tension between the center post and mass A, and tension 2 being the tension force between MA and MB. MA would consist of M1, T1 would consist of T2 as well. So at block A, you have a tensional force 1 that points to the left. You have a tensional force that points to the right. That's tension 2. You have your FGA, force due to gravity, on block A, and a normal force that cancels out that gravitational force. This is the free body diagram for block A. For block B, we have a rectangle with a gravitational force of FGB, and a normal force that counteracts that. And then, since there's no frictional force, there's only tensional force in the centripetal direction, which is pointing that way. That being tension 2. Now, in the problem, they give you frequency in revolutions per second, which means that it will take how many revolutions will it complete in a second. So frequency is revolutions over seconds. To find the tangential velocity in which the blocks are going at, you would multiply the frequency by the distance that it travels. The distance here being 2 pi r, since this is your circumference, and then it's multiplied by your frequency value, so it's distance over distance times revolutions per second, which will give you V is equal to will give you units of distance over second, which is your velocity. Now, knowing that value, we can start working on our calculations. So basically the forces in the centripetal direction. So we'll mark where it is accelerating. So assuming that it's accelerating this way, this is your centripetal acceleration, and in block B it accelerates that way, since it points in that direction. So solving our free body diagrams, FGA and the normal force there would cancel out. Same with this one, because they're not accelerating up or down. So we only have acceleration in the centripetal direction, and we're assuming that in tension 1 it's accelerating to the left or to the center post. Same with mass B. Now, if we have set up our equations, we have tension 1 minus tension 2 is equal to mass times AC, where AC is equal to V squared over R. So if we plug in our values, it would more or less be T1 minus T2 is equal to mass A, MA times 2 pi radius A times F, since we found our velocity value here. If we found our velocity value here, this is our velocity, our tangential velocity, but this is squared over RA. We don't know what T2 is equal to, so we will write the equation for that one. So it would be T2 is equal to mv squared over r. Plugging in your known values, you know it's mb times 2 pi rb f squared all over rb. Simplifying this out, you would get mb times 4 pi squared rb squared all over rb. Simplifying this out, you know that your rb down in the denominator will cancel out with 1 in the numerator. So then your final equation becomes T2 is equal to mb 4 pi squared rb f squared. You can rewrite it in whatever way you want. And then now, since you know what that is, what tension 2 is, you can plug it back into T1 minus T2 is equal to mb 2 pi r, not b, that's a, times 2 pi ra times f squared over ra. You can simplify this out and you will get ma 4 pi r pi squared ra. Now you plug in your known values. You know what the value for T2 is equal to. You know what T1 minus T2 is equal to. So T1 is equal to ma 4 pi r pi squared raf squared plus mb 4 pi squared rbf squared. You will then simplify this, so you will get 4 pi squared f squared times mara plus mbrb. So that is how you do question 8 on homework 5.